Hello everyone and welcome to the chapter number 52 of Blender Master Course Simulation Nodes in Blender. In today's chapter, we'll be understanding about the simulation nodes or the simulation zone. Also, we'll be creating an amazing animation with the help of these geometry nodes. And for those of you who are new to this course, you can check out the previous 52 chapters from the link of the playlist in the pinned comment. So first of all, let's go to the geometry nodes workspace by clicking here. Then to add the geometry node system, click on the new button in the geometry nodes editor. Now if I press Shift plus A, then here we have a category which is known as simulation, and in this we have the simulation zone. So let's add it over here, and now you can see that we have a system of two nodes and each of them is having the name simulation. So in simple words, we have one simulation input node and one simulation output node. By using these two nodes, we can create some simulations or some animations in the scene, and that too by using the geometry nodes only. Now the way the simulation zone works is that it takes an input, then performs some operation in the middle which depends upon the nodes that we use, and then it gives the result from the simulation output node. And the simulation or the animation that it creates changes from one frame to the next frame. So let's understand this practically. First of all, I'll take the geometry socket of the group input node and connect it to the geometry socket in this simulation input node. Then for the output, I'll connect this socket in the simulation output to the geometry socket in the group output node. So now that all of the nodes are connected with each other, you might be expecting that it would have created an animation, but if I press the space bar to play the animation, then you will notice that no animation is created till now. Let's take the pointer in the timeline editor back to the frame number 1. So to create the animation, we need to add some nodes in between the simulation input and the simulation output node. So suppose you want to create an animation where the position of this cube changes by a particular distance in a particular axis. So for this, let's first add the transform geometry node, using which we'll control the position of the cube. So press Shift plus A, go to geometry, and in the operations, select the transform geometry node. We'll place it over here, and now if I go to the translation in the y axis and change it to a value of 0.1 meters, then now what will happen is that the simulation nodes will create an animation where the position of this cube will change by 0.1 meters in the y-axis, and this will happen each and every time the frame changes. So if I press the space bar to play the animation this time, then now you notice that we have this animation where the position of the cube is changing in the y-axis by 0.1 meters frame by frame. Also you can try the same thing with the other parameters in the transform geometry node. For example, if I take the pointer to the frame number 1 again, and suppose I change the rotation in the y-axis to 5 degrees, and if I again play the space bar, then this time we have an animation created where the position as well as the rotation of the cube is changing with each and every frame. Now suppose you want to create an animation where we can see each of these cubes frame by frame, and it should be like the scaling will also reduce as the number of cubes will increase. So let's try to create it practically. First of all, I'll change the rotation value back to 0. Then to view the cube each and every time the frame changes, let's add the join geometry node. So press Shift plus A, go to geometry and select the join geometry node. We'll place it after the simulation input node and connect the group input to the geometry socket in the join geometry node. Let's also increase the translation to 1 meters, and now if I take the pointer back to the frame number 1 and play the animation again, then you can see here that it creates an animation where we can see each and every cube separately in the 3D viewport whose position is being changed by a value of 1 meters. And this is because we added the join geometry node and connected it to the original cube. Also, if you want to create the animation where with each passing frame the scale value also reduces, then for this you can either go to the scale parameter in the transform geometry node, or you can add the scale elements node. But for now, I'll be using only these values to create the animation where these cubes will scale down. So if I change the value in all the 3 axes to 0.95, then in this case, the scaling of each of these cubes will reduce to 0.95 times the cube on the previous frame. So if I take the pointer to the frame number 1, press the space bar to play the animation, then you will notice that the position as well as the scaling of the cubes is changing with each and every frame. So this is how the simulation zone works in the geometry nodes editor. It creates the animation depending upon the nodes that you add in between the simulation zone, and the change with each frame will depend upon the values that we add in the different parameters of these nodes. Now moving ahead, we'll be creating an animation where we'll be controlling the position of the cube or any object by using another object like an empty object in the scene. So for this, first of all, I'll remove the transform geometry node from here by pressing X. Let's connect the geometry socket in the join geometry node to this geometry socket in the simulation output node. Let's also take the pointer back to the frame number 1. Now since we want to create the animation where the position of this cube will depend upon some other object like the empty object or something else, so in the 3D viewport, press Shift plus A, then go to empty and select the plane axis. Let's scale it up by pressing S, and now you can see that an empty object is created which does not have any mesh or volume. It is simply existing in the scene. So I'll select the cube again. To control the position with respect to the empty axis that we added, we need to add the transform geometry node after the group input. So press Shift plus A, go to geometry, and in the operations, select the transform geometry node. We'll place it over here, and one thing to notice here is that we have not added this transform geometry node in the simulation zone. Whichever nodes we add in between the simulation input and the simulation output will only be considered the part of the simulation zone. Now I'll go to the scene collection. Let's drag the empty object into the geometry nodes editor, and to use the empty axis to control the position of the cube, first I'll change this to relative and control the location socket to the translation in the transform geometry node. Now before playing the animation, if I go to the 3D viewport and select the empty axis and try to move it, then you will notice that a copy of the cube is also moving along with it. So for now, I'll right click. Now with this empty axis selected, if I press the space bar to play the animation and try to move the empty axis like this, then you will notice that we have these multiple cubes being added in the scene depending upon the position of the empty axis. To make it look better, let's select the cube again, go to the frame number 1. Let's also bring the empty axis back to the original position. So I'll select it, press Alt plus G to clear the location of the empty axis. Now with the cube selected, I'll go to the geometry nodes editor. Let's scale down the cube to something like 0.7, and suppose we want that in the animation, the scaling of the cubes should also change. Then for this, let's add the scale elements node in the simulation zone. So press Shift plus A, go to mesh, and in the operations, select the scale elements node. Let's place it over here. Now if I change the scale value to a value of 0.9 or maybe 0.91, then this time with each of the passing frame, the scaling of the cube will also reduce to 0.91 each time. So to play the animation, I'll select the empty axis again, press the space bar, and if I press G to move it like this, then you will notice that it's creating this amazing animation where the scaling of the cubes is also reducing. Now I'll take the pointer back to the frame number 1. Let's also clear the location of the empty axis by pressing Alt plus G, select the cube again, and in the geometry nodes editor, we'll do some changes in the scaling in order to make the animation look much better. So first of all, I'll increase the scaling in the scale elements to something like 0.96. Let's also change the scale in the transform geometry node from 0.7 to a value of 0.8. Now let's select the empty axis again, press the space bar to play the animation and move it like this. And with this we have a beautiful animation created where we have so many different cubes and their size is also changing, and we are able to control all of this just by moving the empty axis. Now I'll go to the frame number 1 again. Let's also clear the location of the empty axis one more time by pressing Alt plus G, select the cube, and now suppose you want to save this animation in the timeline editor, and for this we need to insert different keyframes at the different frames of the different positions of the empty axis in the timeline editor. So first of all, I'll go to the side view by pressing 1 on the numpad, select this empty axis, and with this empty axis placed on the 3D cursor, I'll press I to insert the keyframe. Now we have a keyframe inserted at the frame number 1. Let's take the pointer to the frame number 40. Let's also change the position of this empty axis by pressing G, and I'll place it over here. Let's insert a keyframe at this position also. So press I, and we have another keyframe inserted over here. Now if I take the pointer back to the frame number 1 and play the animation, then you will notice that we have an animation like this being created in the 3D viewport. To make it look better, I'll select the cube again, and we should change the scaling in order to give it a much better look. So I'll go to the transform geometry node, and in the scale value, I'll enter the value equal to 1. This will scale up the cubes, and for the animation, I'll change the value of scale in the scale elements node to something like 0.92. Also, if you want, we can create this animation with some other object like maybe a UV sphere, and to do this, instead of the group input node, we'll be using the UV sphere node. So press Shift plus A, go to mesh, and in the primitives, select the UV sphere node. We'll place it over here, connect the mesh socket to the geometry in the simulation input. Let's also connect the mesh socket to the geometry in the transform geometry node. Let's take the pointer back to the frame number 1 and play the animation again. Now we have this UV sphere being animated, and just like this, you can replace the UV sphere with any object that you like. For today's chapter, we'll be creating a simple star in the scene and replacing the UV sphere with that star. So to model the star, let's first add a plane in the scene. So press Shift plus A, go to mesh and add the plane, tab into the edit mode. To focus only on the plane, press the forward slash button. Let's also go to the top view by pressing 7 on the numpad, and we'll need some more vertices. So right click and select subdivide. Now to model the star, I'll select this vertex. Let's move it up in the Y axis like this and place it over here. Then I'll select this vertex. Let's move it in the X axis like this. Then select this vertex, move it up in the Y axis and place it over here. Let's do the same with this one also. We'll move it in the X axis like this. And now we need to change some position of the vertices in order to finalize the star. So first of all, I'll select these top 3 vertices and we'll move them down in the Y axis like this. Also, we need some more points in between these 2 edges. I'll right click and select subdivide again. Then I'll select these 2 vertices, move them down in the Y axis and place them over here. Let's also scale them down in the X axis. So press S, then X and scale it down like this. To make it look symmetrical, I'll select this vertex and move it down slightly vertically in the y-axis. Let's also select these two vertices at the bottom and scale them down in the x-axis like this. Now our star looks completely ready. To give it some thickness, press A to select everything and extrude it in the z-axis. Now let's come out of the edit mode, and this is how the star is looking in the scene. Now to give it a realistic look, let's apply the bevel modifier to it. So go to the modifier properties, click on add modifier, and in the generate, select the bevel modifier. Let's increase the number of segments to a value of 3, and now it looks perfect. To give it a smooth look, I'll right click and select shade smooth. Now to create the animation by using this star instead of the UV sphere, I'll first press the forward slash button to view the rest of the objects. Then I'll select this UV sphere and we'll copy all these geometry nodes from here and paste them in the geometry nodes of the star that we created. So press A to select everything, Ctrl plus C to copy. Now let's also delete this from the scene. So press X to delete, select the star, go to the geometry nodes editor and click on the new button. Now I'll select these two nodes, press X to delete, and to paste the nodes that we copied, simply press Ctrl plus V. The reason why we see a UV sphere is that in the geometry nodes editor, we added this UV sphere to be used as the input. So I'll delete it from here, then I'll take the group input and connect it to the simulation input and also to the transform geometry node. Now to create the animation again, I'll go to the top view this time by pressing 7 on the numpad. Let's take the pointer back to the frame number 1, select the empty axis. Let's also delete all the keyframes that we previously inserted over here. So in the timeline editor, press A to select everything, X, and click on delete keyframes. Now at the frame number 1, the position will be at the 3D cursor. So press I to insert the keyframe. Let's take the pointer to somewhere near frame number 20. Let's give it a random position. So press G to move it and place it at any random position. Let's insert a keyframe by pressing I, and we'll do the same thing a few more times in order to create the complete animation. So let's take the pointer to the frame number 40, and this time I'll change the position of this empty axis to over here. Press I to insert the keyframe. Take the pointer to the frame number 60. Let's move it down like this. Press I to insert the keyframe again, then I'll go to the frame number 80, and this time I'll move it over here. Let's insert a keyframe again, and let's do the same thing one more time at the frame number 100. Let's place the empty axis over here, press I to insert the keyframe, and now the animation is ready to be seen. So I'll go to the frame number 1, press the space bar to play the animation, and now we have this animation created with these stars that are moving and scaling down. Now let's also give it some glowing material. So for this, let's first go to the render view, then I'll select the stars and change the window to the shader editor. Click on the new button, and since we need to make the glowing material, so in the principal BSDF, I'll go to the emission. Let's change the color from here and let's keep it to something like pink color, and yes, it completely depends on you that which specific color you need as the emission color for these stars. Let's also increase the strength to something like 2 or maybe 3, and to apply this material, let's go to the geometry nodes editor again, then press shift plus A, go to material and select the set material node. We'll place it over here, and from the list of the materials, I'll choose this material.001. To view the emission effect properly, go to the composting, turn on the use nodes, then press shift plus A, go to filter and select the clear node. Place it over here, change the clear type from streaks to bloom, change the quality to high. Let's reduce the size to something like 6, and to view the result, let's go to the geometry nodes workspace, and from here, change the compositor settings from disabled to always. With this, we now have these glowing stars in the scene, and if you want, you can even control the amount of this glow from the composting workspace, like you can try changing the bloom size, and in this way, you will be able to modify the scene. So try to play around with these settings, try to change the color of the stars or the emission strength or maybe the position of the empty axis in order to create a different type of animation. And with this, we now arrive to the end of this chapter. Today we learnt about the simulation zone and even created a simple animation using it. So our next chapter will be the chapter number 53, Introduction to Compositing. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.